Hi everyone. In the previous video, we learned the different types of equal sign available in Mathcad. So for example, when you want to assign a value to a variable, if I type x colon 1, enter. So here I am assigning a value to a variable. Another equal sign is evaluation equal sign. So if I type x, type equal sign, it will return the value of x for me. Another one is symbolic equal sign. Again, if I type x, control dot, here again, this operation will return the value of x for me. This symbolic equal sign is used when you're typing symbolic equations in Mathcad. There's another type of equal sign in Mathcad which is used when you want to define systems of equations. So for example, if I have x plus y, control equal sign, 5, enter. So here I am defining this equation which has two unknowns. This one is a Boolean equal sign, which I will get back to shortly in this video. So after these different types of equal sign, we learned how to convert units in Mathcad. We learned how to create 2D and 3D plots for a function. We learned some basic operations available in Mathcad between vectors and matrices. We learned how to add text and edit those texts in Mathcad. So here in this video, I'm gonna review some additional operations in Mathcad. Then we will go through some available tools in solving systems of equations. So before I start, I would delete these ones here. So I would go to Math, I would go to plots, then I would add XY plot here. Here if I type X, then Shift and enter together, type Shift and this vertical bar, then type X, then again Shift enter. Another function that I'm gonna define here is square root of X. So I can find it here, go to Math, this one here, and the shortcut key is the backslash. So I can add this function here, then use the arrow key on keyboard, and here you can define your independent variable and then enter. So here you can see that we have multiple functions plotted here. This blue one refers to the first one, and you can see this blue line under the first function. The second function is black, and you can see this here. The third function is in red, which is the square root of x. So this is how you can add plots of different functions in one diagram. Another option is to, so when you're here, you can go to plots, and here click on add trace. And here you can see that the shortcut key is Shift enter. So now if I click on this command here, I can add another function. So for example, x to the power of 2, enter. Here you can see another function, another plot is added here in this diagram. So here, what if I define a certain range for my independent variable? So for example, if I type x colon -4, comma, the second number would show me the interval -3.9, and the last number would be the last number of my range, 4, enter. So you see the x-axis is now from -4 until 4. Another option is to define the functions as f of x and g of x and so on. Column x, enter, g of x, column shift and this vertical bar, x, enter. So I have these two functions, and here instead of x I can type f of x, and here I can type g of x. Now this error that appears here is because I need to move my diagram below my functions. Once the diagram is below the defined functions here, there's no error. So this is another option to show your plots of functions. So as another basic operation in Mathcad, I'm gonna delete these ones here. So here I'm gonna show you how to use the integral and differential commands. You can type Control Shift and D to get the derivative of a function, or for the integral command you can type Control Shift and I. So here, for example, if I type Control Shift D and then x in the denominator, use the arrow keys on keyboard, and here open a parenthesis, x to the power of 4. Now here, instead of using the column, or the evaluation equal sign, I'm gonna use the symbolic evaluation equal sign, because I have some variables here that are not yet defined. So control dot would give me the result of this derivative here. You also have the option to use go to operators under Math tab, and here you can find this derivative command, and the shortcut key is Control Shift and D. We have also integral command, and the shortcut key is Control Shift and I. So here I would use the Control Shift and I command. Now here I would type the result of this derivative here, 4 times x to the power of 3 times the dx, control dot. Here you can see that we are back to the original function here. As you know, integral is the reverse of derivative function. So as another example, I would type Shift Control D, x, use the arrow keys, and here 1 over x, control dot. Here we have this derivative, and here notice that there is no need for parentheses here, and the result is correct even if you don't use the parentheses. So here I'm gonna get the integral of this function here, Control Shift I. Here I would type open parentheses, -1 over x to the power of 2. Then use the arrow key and type x, control dot, and again we are back to the original function. Another example would be d Control Shift T, open the parentheses, backslash and X, Control dot. Here we have the derivative of square root of X, and the integral would be Control Shift I. So here I would copy this function here, and then times dx, Control dot, and the result is the original function. Here you can define the lower and upper bounds for your integral. So for example, if I type 0 for the lower bound and 2 for the upper bound, then enter. So the result would be a scalar value for you. So here I'm gonna give some more examples. Control Shift T, natural log of X, Control dot. So here you need to type dx in denominator and then enter. And again, if you get the integral of d over x, you would get natural log of x. As another example, Control Shift D, and here e to the power of x, Control dot. You know that exponential of x, the derivative of this function is the same as the original function. And if you get the integral, Control Shift I, and here type exponential of x times dx, Control dot. Again, you would get the original function here. So as I said, we use this symbolic equal sign because we are using an undefined variable in our equations and functions. So, and if you want to have the derivative of a function at a specific point, so for example, I want this value, so if I put it here and define x here as 5, enter. So here, instead of a function, you would get a scalar value for your derivative. Now that I have defined x here, there's no need for this symbolic evaluation sign. So I can use this evaluation equal sign and I would get the same result. So in Mathcad, whenever you assign a value to a variable, Mathcad would remember that value unless you use the clear command. So here if I type 1 over x equal sign, if I type x to the power of 2 equal sign, so this is defined in Mathcad, and from now on it will consider x as 5. An option that I have here, I can type clear, open parenthesis, x, and then enter. So now if I type x and then equal sign, x is no longer defined in my sheet. So always make sure to clear your variables before you continue with other problems and examples in your sheet. And here I can also open a new sheet or Control A and delete all of these equations here. Now I'm gonna give an example of unity vectors. So we have 3 unity vectors, I, which is defined as Control M, open the square bracket, and here type 1 tab 0 tab 0. J is another unity vector, which is defined as Control M 0 tab 1 tab 0. Use the arrow key, and K is defined as 0 tab 0 tab 1. As I mentioned in the previous video, vectors are shown as columns in Mathcad. So here I'm going to define 3 different vectors, which are different combinations between these unity vectors. So the first vector is I minus j plus k. Enter. B is defined as 2 times I plus k, and C is defined as I plus j minus k. Now I can evaluate different operations between my vectors. So for example, A shift asterisk, B equal sign would return a scalar value because I'm using this dot product between my vectors. Now if I type A control asterisk B equal sign, here it returns a vector because the result of a cross product between vectors is a vector. Now if I type A control asterisk B, so I would put this inside parentheses, A B, it outside the parentheses, and control asterisk C equal sign. Again, A, this cross product would give me a vector, but this dot product would give me a scalar value. Now what if I type, open a parenthesis, A control asterisk B control asterisk C equal sign. Again, the result of this parenthesis is a vector. The cross product between 2 vectors would be a vector. And here you can evaluate some properties of vectors. So for example, here if I change the direction of this multiplication, so if I type C asterisk A control asterisk B equal sign, the result would be the same, because in dot product the order of your terms is not important. But if I change the order of terms here, so for example if I type C control asterisk A times B, A control asterisk B, then equal sign, the size of my matrix is the same, but the direction is reverse. So I have here -3, 1, -2. Here I have 3, -1, and 2. I can also find the angle between 2 of the vectors here. So for example, I want to find the angle between vector A and vector B. I can type theta, so Q, control G, column, A arc cosine, open the parentheses, and here use the forward slash. In the numerator type A dot product B, and in denominator shift the vertical bar A times shift the vertical bar B. Then the equal sign, and here we have the angle between vector A and vector B. Now if I type degree here, this angle that I have here is in the units for this value is radians. Now if I change it to degree, enter, now I have the angle in degrees. So Mathcad is a very powerful tool in evaluating properties of your functions. So that being said, I'm gonna give another example for vectors. So here I have this example. Given that the force vector and displacement vector are described as Fi plus J plus K Newton, and delta x is negative 2I plus J plus 3K meter. A, find the angle between these two vectors. B, how many joules of work is done as the force F moves along the path delta x. C, if x sub 1 is defined as 2I plus J plus K, what is x sub 2? And finally, find the torque vectors of the force F at x sub 1 and x sub 2. So back to the Mathcad file, I'm gonna define the unity vectors again. I is equal to 1 tab 0 tab 0. J is 0 tab 1 tab 0, and K, control M, 0 tab 0 tab 1. Now here I'm going to define the force vector. F is equal to I plus J plus K. So as I'm going to use the units, I need to put this vector inside the parentheses. So I plus J plus K, outside the parentheses type N, capital N, enter. So N here is newtons. Now displacement vector delta x, we can type D, then control G, and it will change D to delta. Delta x is equal to negative 2 times I plus J plus 3 times K. Again, I would cut this part, control X, open the parentheses and paste it here. Now outside the parentheses type M, enter. Again, this M here is the meters unit for displacement vector. Now I have x sub 1, so type x, the square bracket, 1, column, 2 times I plus J plus K. Again, you need to put this inside a parenthesis. Outside the parentheses, type M and enter. Now the first question is asking for the angle between the force vector and the displacement vector. So for theta, type Q, Control G, column, arc cosine, so A cosine, open the parentheses, the forward slash, in the numerator type F, dot product, delta X, and in numerator type absolute value of F times absolute value of delta X. Then the equal sign. So here we have the angle in radians. Now if I type degree and then enter, here I have 72-degree angle between these two vectors. The second part is asking for the work which is done with this force along this path. Notice that work is a scalar value, so you need to find the dot product between these two vectors. So I would define work as dot product of delta X shift asterisk and vector force vector. Then the equal sign, 2 joules. As you see, automatically Mathcad returns the value of work in joule units. That's because you have already defined force and displacement in newtons and meters. Now here, the second part of this example, the third part is asking for the value for the vector of x sub 2. So here we have x sub 1, x sub 2 would be defined as x sub 1 plus delta x. Then the equal sign will give you the vector for x sub 2. So from here you can say that x sub 2 is 2 times j plus 4 times k. Enter. And the last part of the example is asking for the torque vectors. Notice that torque vector is a vector opposite to the work that we already calculated. So here for torque at position 1, so T sub 1 is defined as x sub 1 the cross product, so control asterisk, and F, so the cross product between vector of the position at position 1 and the force vector, and then equal sign will give you the torque at this position, and the units is the same as the unit for work, but this one is vector, this one is a scalar quantity. And the torque vector at position 2 is defined as x sub 2 cross product F. Then equal sign. Again, we have this vector for the torque vector at position 2. Here notice that it is returning the value of the torque vector in newtons, which is not true. This is because I typed this vector for x2 here without any units. So this is an extra one here. I can get rid of this because it is already defined here. So if I delete this term here, I would get the correct units for my torque vector here. So torque and work, both of them are in joules. Torque is vector, but work is a scalar value. And always make sure that when you add units to your vectors or scalar values, always add those units because it will give some error if you don't do that in Mathcad. Now in this example, I'm looking for the roots of a function. So suppose that we have this range for my independent variable, -10, -9.9, and the last number 10, enter, and now I'm defining f of x as sine of x. Enter. So one very simple method is to use the plot. So go to plots, xy plot, and here I would type f of x, or you can type sine of x, then the arrow key, and here type x, enter. Now we have the plot for sine of x, and you can see what are the roots for this function. We have -9 something, we have -6 something. So this is a very simple method for finding the roots of a function in Mathcad. Another way is to use the root command. So if here I type root, open the parentheses, f of x, comma x, and then I define the range of my independent variable. So for example, -10 and -8, then the equal sign, it will return the root of the function in this range between -10 and -8. As another example, I would type root f of x and x, comma, and then the range for my x value would be -8, comma, -6, and then the equal sign would return this root here between -6, -8, and -6. And you can go on and type here root f of x and x, and then the range you want, -2, comma 2, then the equal sign, and here it will return this root here, x is equal to 0. Another option in Mathcad is to use the solve block. So go to Math tab, and here click on this solve block. So here it will open a block for you. It has 3 different parts: guess values, constraints, and solver. In front of guess values, you can put your first guess. So say I would guess my first value as 0, and then for the constraints, I would type my function sine of x is equal to 0. And then here for the equal sign, you need to use the Boolean equal sign. So control and equal sign. So for constraints in solve block, you always need to use this Boolean equal sign. So make sure it is only used for constraints, not for the guess values. So here I would like sine of x to be equal to 0, and now in front of solver type find x, and then the equal sign. It will give you 0 as the root of the function. If I change my guess value to 2, then enter, it will give me 3 point something, which is this root here, the x value that makes the value of sine of x 0, 3 point something. So it depends on your first guess here. So say for example if I type 6 here, then enter, it will give me this root here after 6. So these are 3 different options in finding the roots of a very simple function in Mathcad. Here as another example, I would continue in this sheet, and as I'm continuing in this sheet, I'm going to make sure that to use the clear command, clear x, enter. Now I would define a new range for my x, -2, -1.9, and the last number 3, enter, and my function I would define it as 2 times x to the power of 3 -3 times x to the power of 2 -6 times x plus 3, enter. Now again, the most simple method is to use the plot. Here I would type f of x, and here x as my independent variable, and then enter. So here from this plot you can say that we have 3 roots for this function. So we have 3 roots. This is one method. The other method is to use the solve block. So go to math, click on solve block, and here for my first guess I would type x is equal to 0. Then in front of constraints I would type the function 2 times x to the power of 3 -3 times x to the power of 2 -6 times x plus 3, and then Boolean equal sign, control equal sign, equal to 0, then use the arrow key, and in front of the solver type find x, then equal sign. So from the plot you can say that this root which is found here is this one here, close to the 0, which is the first guess in my solve block. Now if I change it to -1, so this time the root which is given here is this one. So it depends on your first guess. If I guess 2 as my first guess, then it will return 2.4 as the root of this function, this root here. There is another method in Mathcad to find the roots of a function. So here again I would make sure to clear X, enter. Now if I define a new function here, g of x as x to the power of 2 plus 3 times x plus 2, enter. So this method is polyroot command. Now I'm gonna define a new vector here, which include all the coefficients of this function here with respect to x. So I would define this vector as g of x, then control dot, and this symbolic equal sign will return the function again here, and on top of this symbolic equal sign I'm gonna type a new command, type coefficient comma x, then enter. So this command will return the coefficients of this function for x in terms of a vector. So I'm assigning this vector to v, and now here I'm gonna define a new variable as capital X, and then use polyroot command, polyroots of v, then the equal sign. So here, this polyroot command is returning the two roots, which makes this function equal to 0. As another example, again I would clear x here, enter. Now I'm defining f of x as x to the power of 2 plus 6x, enter. Again, I'm defining this variable as coefficients of this function. So f of x, then control dot, and on top of this symbolic equal sign, type coefficients comma x, enter. Again, we have this vector, which are the coefficients of my function here. 0 because there's no constant value here, 6 is the coefficient for x, and 1 is the coefficient for x to x squared. So here, if I define capital X as the solution of this example and use the polyroots command, equal sign, so these are the two roots for this function and will return this function as 0. Mathcad is also used to solve systems of equations. So suppose that we have x and y as our two unknowns for a system of equations, and I'm gonna solve this system of equation using the solve block. So here from Math tab I would click on solve block. Before above the solve block I would make sure to use the clear command, clear x, enter, and clear y, enter. So here inside the solve block in front of guess values, I would put 0 as my first guess for x as well as for y, then use the arrow key, and here for the constraint I have two equations. So sine of x plus cosine of y, and then the Boolean equal sign, control equal sign, 0.5, use the arrow key, and as the second constraint, my second equation is x times y, Boolean equal sign, 0.2. Enter. And here, if you use the find command, find x and y, then the equal sign, you see that the solver is moved here, so you don't need to type in front of solver. Now you have your x value and y value here. So here, using the solve block, I solved this system of 2 equations, 2 unknowns. Now, if I change my first guess, so as 2, for example, enter, you see that we have different solutions for this equation. As you know, sine and cosine functions have multiple roots and multiple solutions. So the solution depends on what specific range of your variables that you're looking for the solution. And here you can use the backspace and make this solve block smaller. So suppose that we have 3 equations and 3 unknowns. So here, suppose that we have x, y, and z as our unknowns. So make sure to clear x, enter, clear y, enter, clear z, enter. So again, I'm going to use the solve block here. As usual, my first guess for x is 0, enter, y is 0, and z is also 0. Now for the constraints, I'm adding my equations. Negative x plus y, negative z, Boolean equal sign, 10, enter, x minus y plus 2 times z, Boolean equal sign, 5, enter, and the third equation is x plus 2 times y minus z, control equal sign, negative 8. Now here, use the find command, x, y, and z, then the equal sign. So here's the solution for this system of 3 unknown 3 equation. So x is negative 14.333, y is 10.667, and z is 15. So there's another method to solve this system of equation. So here I would need the matrix of the coefficients for these 3 equations. So I would define M as a matrix, a 3 by 3 matrix. So we have 3 equations and each equation has 3 coefficients. So from the matrices and tables tab, I would select a 3 by 3 matrix, and here as my first element, I would type -1, use the arrow key, 1, 1, -1, tab. So here I have x minus y plus 2 times z, so 1, -1, 2, use the tab key, 1, 2, and -1. So this is a matrix of coefficients of this system of equation. Now I'm gonna define another variable here, and this would be a vector here, and it would be the result of these equations. So type 10, tab, 5, tab, -8, enter. Now the command that I'm going to use here is linearly solve m and y. So type L, solve, open the parentheses, m and y, then the equal sign. So it will return the same solution that the solve block returned. So this is another command, and here you can define, before linearly solve m and y, you can define a variable here, say for example capital X, enter. So here if you type x sub 1 equal sign, it will return the second element in this vector, and that's because origin is set to 1. So go to calculation. The origin is set to 0. If you set it as 1, then the first element would be -14.333. Now x sub 2 equal sign will return the second element in this vector, and x sub 3 equal sign will return the third element in this vector. So here is how we use linearly solve command in Mathcad to solve systems of equations. So as the summary of the last part of this lesson, in order to find the roots of a function, you can plot the function over xy diagram, or you can use the solve block. You can use the root command or the polyroot command. For solving systems of equation, you can again use the solve block, which is available from Mathcad, or you can use the linearly solve command as with explained here. And always make sure that when you're using this find command, it should always be inside this solve block. So this is what I wanted to teach for the lesson 2 of Mathcad, and thank you for listening.